Okay, we are in a discussion of AWS Solutions Architect, and today we're going to discuss another important topic under AWS storage solutions. What we call today, we move into a EFS, Elastic File System. Actually, my previous videos, we already discussed two other storage solutions, which is provided by AWS. The first one is we discussed S3 object storage bucket system, right? S3 buckets. And then previous video we discussed EBS, elastic block storage, which is basically a hard disk to easy to compute instances. They are coming up with a different type of disk, solid state drive SSD, and then HDD mechanical hard disk drive. So this one is really important because this is file network file protocols, NFS file systems, so file directories. So let's talk about Amazon EFS file system, right? Before I'm moving into further into this slide, I'm just going to talk you through. All of you probably has on-premises experience. So normally in on-premises, if you use Active Directory, we have file servers. So Windows file server, and then this file server we create a hard disk and different sort of folders, and through the Active Directory we give the permissions into each folder. You can name them the marketing, accounting, right, HR, IT, and then we give sort of permission to access these folders as a group or as an individual through Active Directory, right? Giving permission through Active Directory. And then what we'll do, we map this drive into users' local computers. When users start their computer, these drives will be mapped automatically through Active Directory configuration, and the files which they have either group permission or single permission, they are able to access. But the files are not in a local computer. Files are in a file server in your server room, but it remotely will be accessed through one of these network file protocols. That's how we accessing a remote file system from your local computer after mapping, right? So this is a similar file system. EFS is similar to whatever we have in on-premises, but on-premises we discuss about Windows. This EFS is more favorable towards Windows systems, Linux systems, right? All right, let's go forward. Okay, so before we going into EFS, I'm going to bit talk about you about the network file system, right? So NFS, what is this network file architecture, right? So it is a distributed file system protocol that allow client to access file over a network as if they were like local, right? So this is a distributed file system. The file system is located in a remote server, but clients can access them. Looks like they are in your own computer. So this is developed by Sun Microsystem in 1984. NFS enables seamless file sharing across different operating systems. So someone in 90s, 2000 with Java. So possibly you remember they were very popular in Sun Microsystem during that period, right? Sun Microsystem was very popular. Solaris, right? I don't know what happened to them. I think something happened to them. Sorry, that's the stories in the YouTube. You can see uh, rising and falling of Sun Microsystems in the 1990s, 2000. So they were still popular about 2006, 2007. A lot of servers we've been using in the Sun Microsystem as a long time ago. I remember when I working with the IT field at that time. All right, so this was developed by Sun Microsystem in 1984, and now it's sort of developed further. So basically, I'm not going to go into very ins and out of ins and outs of NFS, but basic idea of how NFS works. So client send a remote procedure call request to NFS server. So client sending a NFS server, and server process file operation, and response sent back to client. File appears as local to client application. So basically, that's the main process. How does that work? So purpose and benefit. The purpose is centralized storage, right? So that is in a different location, but looks like local when you're accessing cross platform file sharing. So different platforms, right? Like Linux platform, Windows platform, Mac platform, right? Unix platform. So if they have common protocols, so they can use same file, right? Reduce the storage cost and complexity. So the backing up and all other solutions, the file system is in a one single place rather than each and every computer's the file. So enhanced data consistency and backup. So you can edit a single file with two different users and they can save. Uh, NFS serves as a backbone for distributed environment, enabling storage solutions supporting high performance computing clusters, facilitating what is this? Seamless data sharing across the enterprise networks, right? So let's have a look at key consideration protocol selection. So there are a few other protocols we've been using a long time ago. Some of them are not really popular in these days, but NFS SMB, right, are very very popular in these days, right? So key consideration for protocol selection. So choose protocol that align with your primary operating system. So mainly NFS or SMB, SMB, Windows Enterprise, NFS, Enterprise Linux Unix environment. So choose protocol that align with your primary operating system. So if your operating system mainly used in your office is Windows, then go with Windows. If you mainly using Linux, use with Linux. So performance, NFS and SMB excel for real-time file access, while FTP is better for batch transfers. So FTP, SFTP, secure file transfer protocol and file transfer protocol, right? So these are not actually, that's they are file transferring mainly. Security, modern version of our protocol support encryption, but implementation varies, right? Integration, consider existing infrastructure, uh, Active Directory, Kerberos, etc. Right? Scalability, NFS and SMB handle concurrent access better than FTP. So we're not talking about FTP. So Amazon EFS use Network File System version 4. I know that it support version 4 and 4.1 because of its excellent cross-platform support, right? High performance, robust security features, making it ideal for cloud environment with diverse client system, right? So uh, you can see in the diagram sort of what are the security cross-platform, right? See that in here, performance is high while cross-platform is excellent in NFS, SMB, CIFS, is high and good for cross-platform, but is mainly for Windows Enterprise, right? So both has strong encryption. AFP, I think it's a Apple file protocol, possibly, but yeah, Apple filing protocol here is there. But I don't think it might be using very much, but it not really secure wise and cross-platform. It's a really good. FTP, SFTP, as we know, that's file transfer protocol. FTP, when using SFTP, that's a encrypted file protocol. All right, so we have sort of few uh, pillars about how is these things. So SMB, server message block, common interface file system, sorry, common internet file system. Right. So that's origin was Microsoft 1983, right? And the primary use for Windows networks, right? Native file sharing, authentication, versions SMB are latest, right? So this is best for Windows dominated environment, enterprise network with Active Directory integration. Apple Filing Protocol 1986, right? Mac OS environment, right? Mac file system HFS, APFS, support Mac specific metadata, resource fork handling, right? So legacy Mac environments, creative workflow requiring Mac specific features, right? So FTP, we're not going to talk much about HTTP. So this is file transfer protocol, not much file accessing. Uh, Network file system, Sun Microsystem, 1984. That was rising about 90s, 2000. I remember Sun Microsystem. They were well in the market. I think this something happened to them at that time. Primary use Unix Linux environment, scientific computing, cloud storage solutions. So that is NFS, which we going to talk about today, right? Uh, while NFS is widely used in Unix, Linux environment, different operating system and use cases have given rise to various network protocols, right? Optimized for specific scenarios, right? All right. So as we know now, right? What is this? This is a network file system which can be accessed through many computers. Before we going into the diagram, I'm going to give you a sort of a definition, sort of identification. What is Amazon EFS, Elastic File System? It's fully managed cloud native file storage service provided by AWS, which offers you scalable elastic storage that grows strings automatically. I'm just going to compare this one now. Remember when you have your on premises, you have a server which, let's say, you have a 200 GB hard disk. You got two partitions, C drive and D drive. So C, you install Windows operating system, and D drive, you map to and create that as a shared drive. And then you create folders there, and through Active Directory, you give various permission to your different department. Like you give access some folders to HR, you give IT, you give accounts, you give marketing. So each people has got their drives mapped in their local computer, and then you can access, right? And think about that 200 GB space. When your users keep adding files, the space is filled, and you're going to running out of remaining space, right? So the difference is this one is scalable elastic storage that grows and shrink automatically. So this one, if you add more files, it grows, and if you remove or delete more files, and it removes shrinks. Always you pay whatever you using at the currently, right? It is exactly 245 GB. That's 245. It's not 300. If your hard drive is 500, doesn't matter. Here, it's 245 is 245. Support for network file system protocol version 4 and 4.1. And then concurrent access from multiple AWS resources, right? So, not like EBS. This one can be accessed by number of computers at the same time. The compatibility with both cloud services and on-premises. Once you map with direct connect or VPN, it's like a map drive in your on-premises, like your local drive, so you can access, right? So the major highlight point is serverless architecture and shared access here, right? So also, it designed workloads that need shared data across multiple instances or containers simultaneously. So, such as web applications, Lambda, microservices, and content management system. So here gives you an example. It's just a VPC, virtual private cloud in Amazon, and you could see three different data centers, availability zones 1, 2, 3. That's different data centers, and then data center one got a availability zone. You got two computers, and then middle one doesn't have a computer. Though zone three has a computer. So this when you map the mount target in elastic file system, you could access all of the file system in simultaneously. If you're looking into a zone 1 and zone 3, you could see the EC2 instances. They should have EBS volumes, Elastic Block Store, but these EBS volumes only accessible for themselves, right? Can't access 1 in 3, or you can't access 3 in 1, something like that, right? So, key features of EFS. You can see key features. So this one is encryption, at rest, transit, auto scaling, and serverless, right? Could see how it's a serverless, elastic, POSIX compliance, broad accessibility, high availability. All right. So what is the EFS versus other AWS storage services? Comparing. That's what we do always. EFS, EBS, S3, FSX, right? So you could see access patterns, while access patterns 1, because it's only accessed by, yeah, S3 can be accessed by two different ways. This one is a two different, but this one is a three access platforms. So here the storage service, this is a type. We explain what is the file, block, object, file storage. So what is this best for here, right? So this one is basically what we're discussing is Linux workload requiring shared access, elastic scaling, concurrent access. That is what we considering this one. So this one is EC2, and then S3, right? Object storage. The last one is Windows Enterprise. Last FSX. All right. So performance modes and throughput, right? Remember, I spoke about throughput, how much you can transfer, what rate you can transfer into the drive. So recommended most workloads for uh, general purpose mode, low latency, thousands of computer instances with a sub-millisecond operation, ideal for web servers, content management, home directories. GP, general purpose, throughput 250 megabits per second. Sorry, megabytes per second. Maximum I/O throughput is 500 megabytes per second. Elastic throughput 350. So in between general purpose and max. Provision throughput 400. Provision throughput, right? So automatically scales throughput up or down based on workload demand, eliminate the need to provision capacity in advance. So you don't need to set up capacity in advance. So it will automatically scale up, scale down, right? EFS is storage classes and cost optimization. So it got sort of classes, not many as S3, but as a bit of a clarification so you guys to save some money. So what is the storage classes? So it's got the standard, infrequent access, and archive. So now you know what are the standard normal access and infrequent access is you need to access, but you don't need like in a standard. And then archive, you don't need to access that frequently. So use cases, active data workload requiring high performance, we have to use standard. So there's no minimum duration for that one. Millisecond access. When you need it in frequency access few times each quarter, maybe let's think about camera files, maybe correct or not. You want to see an incident happen in 1 or 2 months back, and there's no minimum duration, and then archive few times per year, 90 days in the minimum duration. So this is a tiered storage strategy, and it's all in between performance versus cost balance when you select in these tiers according to your requirement, right? All right. So let's have a look what sort of security and compliance in Elastic file system. So you could see end-to-end encryption for both data at rest and in transit. No need to modify application. So EFS, data at rest, you can use AWS Key Management Service Encryption, KMS, right? And then in a transit, TLS, Transport Layer Protocol, right? TLS, um, and then access control POSIX permissions, you can set up permissions, and then no key management required in the data at rest. So TLS provide you secure network traffic. Then you can give a permission under permission control, file level access control through IAM, I believe. So data at rest, KMS, eliminating need to build and maintain key management infrastructure. Data in standard TLS, transport layer security, um, and then POSIX. Alright, so user cases and application. This is the same picture coming in now. So you could see how the elastic file system mapping into each region and the zones, right? Ideal for content management system and web servers requiring shared file access across multiple instances, and then enable seamless data sharing between containerized applications, serverless functions, constant file access, and then you got a big data analysis uh, process also. We can use this one. and then Linux workload for shared permission, right? On premises as well. Management and integration. So this is a fully managed service, right? No patch or maintain file infrastructure. Create file system in seconds using a management console, CLIO, SDKs. Seamless integration with EC2 containers, serverless computer services. They all can access this one. Hybrid support. Connect on premises servers via AWS Direct Connect or VPN or unified storage. Right, so could see some of the applications like web applications, shared storage, multiple EC2 instance serving a web application, right? Shared web content and static assist in a one single location, and then big data analysis. So you can use this one for big data analysis and in a development environment, collaborative development workflows, right? So you can use shared repositories, libraries, right? Then content management systems, right? Container persistent storage, elastic container services, elastic Kubernetes services, right? Persistent volume for stateful applications, right? And then benefit cycle stored user cases, right? So this one is automatically scaling, high availability, POSIX compliant file system with the permissions, right? So they are the EFS use case example. So this is it, I believe. So we're going to discuss the last one, FSX, in next week, and that's going to be we completing AWS storage solutions. Until then, thank you very much.